Joining us at the beginner-friendly track here at Spring 1, Day 2. We have another great presentation coming up for you from a dear friend of mine. I dare say a dear friend of mine, all the way from Bristol, not Connecticut, all the way the original Bristol, out in England, the jolly old. And I can't wait to hear more about RSocket and his introduction to getting us started with RSocket. Please, everyone, welcome the one, the only, Ben Wilcock.
Hey, thank you, Bob. It's very kind. And hello, everybody. Thank you so much for coming. I really hope that you enjoy it today. We've got a lot to get through, so I'm just going to share my screen and then we'll get started. So here we go. All right, so getting started with RSocket on Spring Boot. I'm Ben Wilcock, and you can find me on Twitter. There's some details down there. And I'm monitoring the Slack channel, the session getting started with RSocket as well. So if you have any questions, you could put them there, and we'll have a QA at the end as well. So let's go. Quick thing about me, so I work in tech marketing for VMware. I mostly work on Spring marketing, and I like learning new things. And I also like working with things like messaging and protocols. I've done quite a lot of integration in my past life as a developer and as an architect. What about you? Well, hopefully you also like learning new things, and that's why you've come along to this particular session. And you hopefully also have an interest in messaging and protocols and new ways of working, new ways of doing things. And you have no problem with there being multiple ways of doing things, as don't I. I really don't mind. If you've seen RSocket before, that's great. But if you're here, I'm expecting folks to be beginners. So either you're looking for a refresher or you've never seen it before. And that's where we've pitched all the content today. What about RSocket? Well, RSocket is open source, of course, and it's a binary protocol. It works with transports like TCP and WebSockets. It's connection-oriented. It's bidirectional. So rather than client-server, you have this idea of requester and responder. But I don't want to blow your minds too much with that today, so I've stuck to talking about servers in this particular presentation. And it's got multiple interaction models, and that's what makes it slightly different. So you can do request response as you can do with lots of other protocols, but you can also do several more styles. Fire and forget, you can do request of a stream, and you can send a stream and receive a stream. And of course, there are multiple implementations as well. So you can use it on Java, but you can also use it on Kotlin and JavaScript and .NET, and there are more as well, which you'll find on the web. If you want to take part, then the things that you'll need are Java 11. You'll also need Spring, of course, and Java IDE of some kind, and Terminal, probably. I mean, that's what I'll be using. And something called the RSocket Client, which is a downloadable client, which you can use for testing, and it's great. And I'm going to show you how to use that today. What you'll learn, well, time permitting, I'll go through as many of the different messaging styles as I can. And if there's time left, I might even touch on security. But don't worry if we don't get to everything. All the code is online. There'll be a link at the end of the presentation. And you can also follow my blog series about RSocket, which goes into a bit more detail because, of course, you can do that in your own time, at your own pace. Let's get started. So that's the intro done. I'm going to now quit out of that. Let's get rid of that. And first thing that you're going to want to do is create yourself an RSocket project. So the easiest way to do that is to go to start.spring.io. And here we use the initializer. We can build our own project. So I've chosen Java, chosen Maven, 2.3.3 is the version of Spring Boot. And I've also added Lombok, which just makes working with data classes easier, and RSocket. And if I click on the Generate button down here and download that particular project, it brings me to, I can load that into my IDE, and of course I'm ready to get started coding my RSocket server in this case. That's what I'm going to show you today. So very little is needed to actually get started with this straight away. The only thing that you should need to do is to add a application.properties file, and in there you'll set the RSocket server port to the port that you want to use, and I've added lazy initialization as well. But if you were to start that, it would run and it would boot up in a few seconds, but it would sit there with nothing to do because there's no code yet. So that's the first bit. That's easiest way to get started with RSocket is to use start.spring.io. Right, let's move on to the next bit, which is to talk about request response. Now, use request response all the time with HTTP, of course, if you've done anything like that. So I'm going to show a little bit of that now. So we go over here back to our project. First thing that I've done is I've added a data class called message. I've used Lombok to do this. You don't have to, but I have. And all that's going to do is carry a string for us backwards and forwards between client and server, or between requester and responder. So I've added a data class. You can see it there. It's pretty simple. The next thing we're going to do is we're going to add a controller. So back in the application class that I received from the Spring Boot initializer when I opened the project, I've added the controller annotation. I've also added a method here called request response, and that returns a mono of type message. That's the message class that we just had earlier. And it also receives a message class as well. So you see I have my request and I have my response. Message in, message out. I also have a message mapping. That's how I can tell the Spring Boot and RSocket frameworks that I'm going to expose this as an RSocket endpoint, if you like. So that's a really important annotation for this particular piece. Without it, RSocket wouldn't know what to do. And in terms of giving that a name, I've just called it request and response. So very, very straightforward. What's going to happen? Well, as soon as that message arrives, a new mono message will be created that basically just echoes back what we said. So let's test that. So I'm going to run the application server there. There we go, it's just starting up. And do you remember earlier I told you about the RSC, the RSocket Client application? I've installed that on my PC already, so let's give that a try and we'll test it with the RSC Client. So I do RSC. If I tell it to go into debug mode, that's very helpful. So debug, and I want to use the request response style. So I'm going to say request, and then I pass in some JSON which describes the message that I want to send. In this case, it's the string hello. And I'm going to route that through to the request response message mapping. So let's give that a try. Boom, done. So what we saw there was the RSC client going through to RSocket. It sent the message hello, which you can see here. And then down the bottom here, we've got our response. So RSC is a really easy way for you to be able to do some quick testing with your RSocket, but it's not the only way. Let me show you one more. So I'll close that server down now and get rid of that window, and I'll show you how to write a regular test. So here I have a Spring Boot test. So I've put an annotation at the top there. And then I have a piece of setup, which basically turns this test into an RSocket client. It uses the RSocket requester builder, which Spring Boot will give to you. and it will connect over TCP using the port that I've assigned, and then it's ready to send messages back and forth. So here's my test. That's going to test that a request can get a response. As I said earlier, it's expecting a mono, so it uses the requester. It says, here is the RSocket route. This is the message mapping, if you remember. And then it's going to pass the data through, which is a message. In this case, it just says test, and then it retrieves that mono. Then I use the StepVerifier. This comes from the Reactor test package. The StepVerifier can check the response, and once it's been consumed, assert that the message contained the text that I was expecting it to contain. In this case, you said test. So let me run that test now. Okay, a couple of seconds there, but there we go. It's run that test through and the test's gone green. So message was sent, response was received, request response is done. All right, so let's move on to the next one. So everything you've seen there, you can do with, HTTP and other protocols, but I'm here to show you RSocket, and RSocket can do some quite exciting new things as well. So what I'd like to show you is fire and forget. So should we give that a try? I'll just go down here and grab the code. There we go. And then if we go back to our application, we have a new message mapping appeared. So this time I'm doing fire and forget. Just bringing my Slack back up so I can see what you folks are all talking about. There we go. So yeah, sorry, fire and forget in this case. So I've got a new message mapping. And again, the method signature is what tells the Spring framework and the RSocket framework what interaction style I'm expecting to use. In this case, because I'm returning a mono void, it knows actually there isn't really a return from this. It's you receive this message, you work on it, but then there's not any work to do. So that's why I return a mono of type empty. So now we've got that. Again, we can test it in a couple of different ways. So if we go back to RSC, we can use the debug. And this time I'm going to tell it I want FNF, fire and forget. But overall, the data is the same. It's still using a message. So here we go. Oh, that didn't work, did it? Connection. I forgot to run the server. Silly me. Okay, I'll do that now. Let me see. There we go. All right. Bear with me. Embarrassing mistake. Here we go. Server's coming up now. So now, of course, there are two endpoints available, a fire and forget and a request response. Let's try that fire and forget again with the RSC client. So here we go. And that's it. So a message was sent, hello, but the client didn't need anything. There's nothing else for the client to do. So the client's free to get on with the rest of its work. Meanwhile, on the server side, if I show you the log, you can see we received a fire and forget request message, and here is the content of the message itself. So that corresponds to this log entry here. So that's all good. Fire and forget, very useful. You could use that for all kinds of different applications, couldn't you? Okay, so I've done that. Now we're going to have a look at another interaction style, this time request stream. So you can imagine a client sends a request and says, give me some stuff. And then a server or a responder can then stream lots of data back, packet after packet after packet over a long period of time. So if you imagine something like a Netflix or whatever, similar kind of interaction patterns happening there. So let's have a look at the code for that. Here we go. We go back to our RSocket application. Oh, hang on, my bad. I forgot to show you how to test fire and forget. Would you like me to do that? Okay, I'm looking at the Slack channel. I think I'll just do that very quickly. So testing fire and forget. So here we are back in our test method. I've got my test annotation, of course. Again, I'm using the requester, which is something that we constructed in the before all annotated method. This is our connection, our RSocket connection. And using that connection, I'm going to route to the fire and forget message mapping. And again, I send some data and I retrieve a mono. But in this case, it's a void class because I'm not actually expecting anything to happen. It's fire and forget. The StepVerifier is again verifying that this happened. It's saying, okay, here, using this result, just verify that the interaction is complete. There's no more work to do. So let's run that. Just answering the question on the Slack channel there, the terminal is Alacrity, and I'm using omyzsh. And thanks, I think it's cool as well. All right, so there we go. So we've run that test through, and again, it's all gone green, so that's great. So you can unit test these methods, or rather, strictly speaking, it's more of an integration test, but you can integration test these methods as well as using the RSC client. Right, back on with the show. So where were we? I was about to tell you how to do request stream, kind of Netflix style, where you've chosen your show and then they're going to stream the show to you in lots and lots of packets over a period of time. Again, it's pretty straightforward in Spring and RSocket. So here we have our message mapping, and this time I've used the identifier request stream. I also have a different method signature. This time I'm using Reactive Flux. So I'm expecting to get a constant stream of data, not just as an individual mono. And I'm also using the message again as my request. So the request will come in as a message. And then essentially what I'll do down here, just to demonstrate this, is every 1 second, which is what this bit's telling me to do here. So an interval of 1 second, so that's creating a flux that generates a new entry every second. Map that flux, so take the once a second and create a new flux that contains a message. And that message should say, you said whatever you said, but also carry a response number, which is the number from the indexed stream, which you get from the interval method. Hopefully that's clear. If it's not, we can cover that in more detail later. And just for clarity, I'm just going to log out there as well. So let me run that for you. So here we go. So my server's spun up, and now if I go back to my terminal and I do rsc --debug, this time I want stream style, but essentially the data is the same again. I just send one message and then I start to get a stream. Let's activate that stream. Now what you're seeing here is that every time a response comes back, it has a different number. So every second we get a fresh response, and each response has a different number within it. And that will continue now pretty much indefinitely. So that's the first thing you can do. You can test it with RSC. You can use the -- stream to do that. I'm going to stop that now, and then I'll show you how to test it with regular Java. Okay, here we are. So here's how we test a stream. So again, I'm using a test. I am expecting a flux to come back from my RSocket request. I have my requester again. I have the root, and I have told it to pass this message to the request stream message mapping. And then I have my data, which in this case is the word test, and then I retrieve a flux. Then the StepVerifier here is going to be created based on that stream. And I've done something fairly simple here. I've just said consume the next message. So when the next message comes in, consume that message, and then assert the values on that message. Make sure that it contains, you said, test, and then the response has a number 0 for the first one, and then number 1 for the second one. So let's give that a run. Hey, there we go, all gone green. So again, you can test it really easily with Java, or you can do it more manually with RSC if you're just playing about with something. So that's good. Right, I'm going to move on to the last type of interaction. So far we've covered request response. We've done a fire and forget. We have done a request stream. So the last one is where we use a stream out and a stream in. So if you imagine a use case for this, it might be something like, I don't know, IoT, for example, where maybe you've got a sensor and it's permanently sort of sending data up to some place in the cloud, but then maybe you've also got some place in the cloud also requesting data on the same stream. You could do that. So let's give that a try. I'll show you how easy the code is. It's pretty straightforward. I think you'll agree, or I hope you'll agree. So back to our application, and then down here I've got a new message mapping. I've used the identifier for that of stream. And then I have a flux again, flux out. I've called it channel as a method name, and I'm also receiving a flux in. So what I've modeled here is that the inbound flux has a setting, and it's going to tell the outbound flux how often it should resend a new message. So if I sent an inbound, in the settings that are inbound, the flux of messages that are inbound, I could say, send me messages every 1 second, then I could change it to 3 seconds, then I could change it back down to 1 second, and the response stream would speed up and slow down accordingly. So let's give that a try. So if I run that now, here we go. And I'm looking at the Slack. Folks, don't worry, there's GitHub link at the end of the session, and from there you'll be able to find everything that you need, and also to the blog series that goes along with this. So you can learn at your own pace in your own time. It's absolutely fine. Okay, so server's started. Let's go and see if we can get RSC to talk to that. So again, RSC, I'm going to use the debug so I can see what's happening, and then channel. And this time it's slightly different. The data, I've chosen to send a dash. Can you see that? If I put my cursor right over it, I've chosen to send a dash as the data. That tells the RSocket client to go into interactive mode. So every time I press a number on the keyboard, it's going to send that to the responder, and the responder is going to speed up or slow down accordingly. So let's give that a try. Okay, so there we go. So if I say 1, I get a message every 1 second. If I say 3, then it slows down. And I get a message every 3 seconds. And if I say 1 again, then it speeds up again. I get a message every 1 second. So I'm sending a stream of messages up to the responder, and the responder is sending responses based on those settings that I had in the stream. So pretty neat, right? I like it. Unfortunately, we've run out of time, so I won't be able to show you how to test that method with an integration test, but do not worry. All the code that you need, all the code that I've shown you today is available online. Just follow that GitHub link there to the Spring 1 2020 RSocket talk. That's got everything that you need, including the bits that I didn't get to around security. There's also the full blog series, which you'll find at the bit.ly link at the bottom there, bit.ly/RSocket blog. There are 8 posts in that series that go into much more depth about RSocket, so have a look at those in your own time. Thank you so much for attending today. Apologies if it was a little bit fast. There was a lot to get through, but hope you enjoyed it, and I'll pass it back over to Bob.
Back. Thank you so much.
Hello.
Sorry about having to cut Ben short, but the good news is there's a Q&A that you can jump into. Head on over to our Slack channel, the Spring 1 Slack channel, beginner friendly, and there will be a Zoom link posted by our good friend Yvonne, who will send you off to ask your questions so that Ben can finish some of that great RSocket information. It's awesome. This RSocket stuff is great. It's changing everything. And Ben is incredible at sharing all of that. And so we just want to make sure that he has the right time to finish that up. So now we're going to be taking just a 1-minute break. And when we come back, we'll have 2 more presenters for you talking about Spring Cloud data flow. Yes, please. All right. We'll see you back in a few moments.